Now let's take a look at symmetry. So there's going to be two basic types of symmetry that we're going to look at, and that's going to be even symmetry and odd symmetry. So an even function satisfies f of negative x is equal to f of x, and that will make it symmetric about the y-axis if it's evenly symmetric. Now, if you can think back to math 30-1, when we took f of negative x, that was a reflection across the x-axis, right? So that's actually what we're seeing, which makes sense, right? Like you can think of if this is f of x, then think of this part as being like a reflection across the y-axis, right? Because the negative is actually attached to the x in that case. Okay, or vice versa, right? If this was our f of x, then this would be like the negative f of x. So it's the same either way you look at it. Now, if we look at odd functions, well, if you can imagine, so this one is f of negative x is equal to negative f of x. So just for a second, drop the negative. I just want to show you. Like if this would have looked like negative f of x is equal to f of x, well then our function would have looked like this, right? It would have been the same on like both sides, like on the left side here and on the right side, on either side of the y-axis. But it's not. It's actually negative f of x. So that's actually like a reflection over the x-axis, which brings this part and brings it down there. Okay, so yeah, in that case, it's like a double reflection you can kind of think of if our function is actually odd. So you can think of like this point over here, being the same height this way down, and there, but the same distance from either side. Okay. So from there, let's look at some functions and determine whether or not they're even, odd, or neither. So how do we tell? Well, we just plug in f of negative x, right? Just like we saw, because that's what we did in both of these, right? We just plug in negative x and then just see what we get out. Like if we end up getting the exact same function as we started with, well, then it's even. If we end up getting negative version of what we started with, then it's odd. Okay, so then f of x, or f of negative x is equal to, and then what we're doing here is we're just going to put in negative x everywhere that there was an x in the original function. So then plus 5 times negative x squared. Oh, sorry, I forgot the 6 there. Sorry. And then, yeah, go back through it. So now f of negative x is equal to. Now it's really gonna depend on whether or not we're talking about even exponents or odd exponents, right? Because if I have an even exponent and like that's my power, then what's going to happen here is this negative is going to become positive. So this will become positive 6. It'd be the same thing, right? Just going this negative to the power of 6 plus 5, even exponent again. This is going to become positive. So that'd be the same thing as 5x squared. Do you see how that looks exactly like the original f of x? Okay, well that means our function is even. Now, let's write that out. So this is an even function. So therefore, even function. Okay, and then why do we care? Well, again, we're in the curve sketching unit, so let's say that we figured out, this isn't what the graph looks like, but let's say we figured out that the graph, looks, something like I don't know, it comes down here and like that or something. Well, then I know for sure that it's going to look exactly like that on the other side, right? It's going to help us sketch it just by the fact that we know that it's an even function. Okay, let's look at the next one. So again, if I want to tell whether or not this is even or odd, we're just going to put in negative x for our argument here. So then g of negative x is equal to, so this will be negative x in brackets cubed plus 1 over negative x plus 3. Okay, and then we're just going to simplify this up a bit. So g of negative x. So this would be the same thing as like just pulling that negative out front, right? And then x to the 3. So same thing. Plus 1 over, and then this would just be negative x plus 3. And then from here, I'm seeing if I can make it into the exact same as the original, then it would have been the same as f of x, right? Or if I can factor out like a negative, then that would also work, right? So let's try just to make sure. So because it's not totally obvious. So then why don't we go? So I'll go plus, and then what we're gonna do is I'm gonna factor out the negative out of the denominator here. Okay, and then so this will be like 1 over negative 1. Okay, and then we have x minus 3. So now this is like a negative sitting really on my whole term here. So let's write that as negative x to the 3. Now minus 1 over x minus 3. Do you see that that's not going to be the same? It's very close, right? Because like at this point, I might say, okay, perfect, right? I can like factor in negative, like a negative 1 out of this. And then I'd have x to the 3 plus 1 over x minus 3. And that looks very close, right? But just notice that this is x minus 3 on the bottom, and this is x plus 3 now. So it's actually neither. So this, so we could say g of x, or g of negative x rather. I'm going to say does not equal g of x or negative g of x. Therefore, it has no symmetry.